Okay, all right. Oh, yes. Let's see. I don't know why I keep switching that. Let's try this again. All right, that should be better. Should be no more echo. And all right. Hopefully this is better. Hello. Happy Tuesday. I hope you all are doing well. Just wanted to take a few minutes and go over the homework problems if you are stuck on any of these. So what we're going to do is just quickly go through some of these problems. And I should have printed off another one here. But so the first two problems, or the first problem here is just to look at the motion here, the sine wave, and identify the frequency, the period, and the amplitude. So the frequency we defined in our notes is the number of cycles per unit time. In this case, the number of cycles here goes up and down, right? So that is one full cycle in 2 seconds here. And so we say number of cycles per unit time, which is equal to one cycle in 2 seconds, is equal to 0.5 hertz. The second part is the period, t, is equal to 1 divided by f. In this case, 1 over f, or 1 divided by 0.5 hertz. This is equal to 2 seconds. We could also have looked at this graph here, and we could have seen that it takes 2 seconds for it to complete one cycle. Last part is the amplitude. Amplitude is the maximum displacement from the zero, from the equilibrium point. Here, 0 goes up to 0.75, so the amplitude is 0.75 meters. Right, so you guys can do the next one. Number two, Nicole jumps up and down on a trampoline with a frequency of 1.5 hertz. What's the period of Nicole's jumping? The period, right? We know that the period t is equal to 1 divided by f. And if her frequency is equal to 1.5 hertz, then this is 1 divided by 1.5 hertz, which is 1 divided by 1.5 gives us, this is 6.6 times 10 to the negative 1, or this is 0.667 seconds. Right. Number 3, we're going to have to go to this website, and we're going to take some data here. I'm going to do this, let's see how we do this. All right, so we're going to go to this website, fet.colorado.edu/simulation/pendulum-lab. You can also just search for this, and let's go there right now. And this is what it looks like. We're going to try to find the period for the 1 kilogram mass. That's the one that is set up right here. So just start that swinging. I'm going to start the stopwatch here. I'm going to bring that here to the middle. And I'm going to, let's see, pause this. Click start. And then the first data point is 0.3 meters. So there. And then I'll click run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 was 11.54 seconds. So the period of time for, well, let's see if this works. So the period of time for this first one is 1.15. So 1.15 seconds. We then repeat this for 0.5. Stop that. Restart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I missed it. But you get the point, right? So you're going to do that, and you'll finish that analysis there, right? We did this one, I think, in our notes to solve for G. So that one I'm not going to do. And we're going to use a data point we collected for 0.7 meters to find G. This is just like the notes that we did. Let's see. These are all the same as well. Let's see. What else do we have here? Number 6. Hummingbird beats its wings up and down with a frequency of 80 hertz. F equals 80 hertz. What is the period? T equals 1 over F. And so in this case, 80, 1 over that, gives us 0.0125 seconds. 0.0125 seconds. All right, and then I think this last one is going to be the example. Last example I'm going to do with you guys is number 7. So in this case, world-renowned hypnotist Paul Brar the Great swings his watch from a 20-centimeter chain in front of his subject's eyes. What is the period of the swing of the watch? So the length is equal to 20 centimeters. And I'm going to convert that to meters, so 0.2 meters. And we know that the equation for the period is equal to T equals 2 pi times the square root of L divided by G. I want to rearrange this now. Oh, actually, I don't have to rearrange this. This is, to find the period, I just plug the numbers in. So 2 times 3.14 times the square root of 0.2 meters divided by 9.8 meters per second squared. Well, if we do this, we should get 2 times 3.14 times 0.2. Oh, actually, let's see. I'm going to do this part first. 0.2 divided by 9.8 gives me this part. I'm going to take the square root of that, and then times 3.14 times 2. This gives me 0.897 seconds. Now, I want to make sure that you all can do this as well on your own calculators. Notice what I did here was I solved this part here on the inside of the square root first. I did 0.2 divided by 9.8. Took the square root of that, then I multiplied it by 3.14, then I multiplied it by 2. So just make sure you're doing those in the right order. And I guess number 8 we'll do as well, just as an example here. And so in this case, they're giving us the period and they want to know the length. So they say that the period is equal to 0.6 seconds, and they want to know what the length is. So here we're going to have to do a little bit of algebra. So T equals 2 pi times the square root of L divided by G. To solve for L, what we want to do here is first move everything over to this side, and then here we'll do the algebra. So first thing, divide by 2 pi, right? Divide by 2 pi. Those cancel out. Now I have t divided by 2 pi equals the square root of L over G. So t divided by 2 pi is equal to the square root of L over G. To undo the square root, we're going to square both sides. Right? And so on the left side, I have t squared divided by 4 pi squared. So everything on the left side got squared. Is equal to L divided by G. And now the last part here, to get L by itself, I'm going to multiply both sides by G. So times G, right? Those G's cancel. And so my final equation is L is equal to t squared divided by 4 pi squared times G. And then we plug those numbers in, and I'll post solutions on Classroom later tomorrow, or maybe later today. So I hope that's helpful, and if you guys have questions, feel free to send me an email. I hope you all are doing well, and I miss you all. So take care. Bye.